Assalamu alaikum. It's okay. Good evening, everybody. Thank you for registering this webinar, and I hope we have a good time, and also to understand what's RBI program and how could be implemented and use it, and also guide to selecting the best RBI software for your facility as this subject for this webinar. Please, if you hear me, just write one in the chat. Just I would like to know. It's okay. Okay, that's great. Okay, we can start now. That's good. Great. Thank you, Mr. Lopez. Okay. First of all, I have to thank the ANEES, Inspection and Corrosion Control. This website has given me this opportunity to present this webinar for all participants. ANEES is a good website for whom interested on the inspection and corrosion control. It includes multiple of articles, even some case studies, and many good subjects. I recommend to read regarding the inspection and corrosion control. So whoever wants to see more information can call this number and also can visit the website, and I believe it is good and useful. It's okay. Let me introduce myself. My name is Ashraf Al-Wafali. I'm a senior asset integrity engineer working for Bureau Veritas Libya branch. And also I have graduated with a Bachelor of Science degree in mechanical engineering. Also, I have a multiple of professional certificates with a more than 15 years experience in the asset integrity and inspection. I have a CMRP, Certified Maintenance and Reliability Professional, ABI 570, 510, 653, 577, 580, and ASNT NDT level 2 as well. AWS CAWI, and I attended multiple training courses related to management as well as inspection, asset integrity, maintenance, reliability. Anyway, so our webinar agenda today, it is, in fact, we have to understand inspection, or just to start with the definition of inspection. And also because as overview, because as you know, it is only 1 hour webinar, so it is not possible to cover all subjects related to RBI and also inspection. But I'll try to explain, and I'm trying to using this time wisely. Anyway, so also why do we need to inspect the pressurized equipment? The definition of risk, the evaluation of inspection intervals, even risk-based inspection, our main subject or main topic, the benefit of RBI program, RBI standard and recommended practice references, and types of RBI assessment, implementation of risk-based inspection program. And I think something missed is regarding the main subject, or a guide to selecting the best RBI software. Okay. So inspection, this phrase that using, so I think also if somebody familiar with it, and maybe some others needs to need to understand what's inspection. Inspection, actually, it is a word called for the activity performed to verify that materials, fabrication, erection, even examination, testing, repairs, all of this work is carried out on the equipment. Here we are talking about the fixed equipment, or some people called static equipment. Anyway, that's all this activity conform to the applicable codes or engineering, or maybe owner specification or procedure requirements. Here, as inspection in general, we can call for the inspection during construction and also in-service inspection, but mainly we are focusing on the in-service inspection because RBI, in fact, it is related to this discipline. Okay. Anyway, inspection includes the planning, implementation, evaluation of the results of inspection activity during all stages of fabrication, even for turnaround or shutdown, plant shutdown, something like that. It covers external, internal, or on-stream assessment, or maybe sometimes combination of those threes. Here on stream, sometimes it's called NII, non-intrusive inspection. That's carried out, this job carried out during the equipment or equipment is still in the service or an on stream. That means you don't need to shut down or bought out the service of the equipment, or we can call asset of the. In fact, this is to make assessment of the condition of pressure equipment. Also here we can add NDT or NDE, non-destructive examination. So what's the purpose of inspection? Inspection provides information about the current condition of the equipment that's in question, and also maybe, or actually it is provide information to validate the reliability prediction for the equipment during its service, because we have to understand, is our equipment is safe to keep, or to put it in the further service or not, as well as it is by inspection or by gather the results of inspection, we can verify the equipment remaining life, or estimate the equipment remaining life. So this is in general the definition of the inspection. So in fact, why do we need to inspect the pressurized equipment? This is a question in the table, okay? Sometimes you are in meeting with our department and some people ask you this question. So how could you reply, okay? In fact, first of all, it is to the purpose of the inspection or in-service inspection that we are talking about, to determine the physical condition of the fixed assets and determine the type and the rate and the cause of damage mechanisms, and also the associated deterioration that came from that. What come with that damage mechanism, and what will be happen, or also what's the condition for this for our equipment, is it okay or not, and also to find out, it can be, as I said before, it can be put in the further service or not. Also to another purpose, to identify the damage that could result in process safety incidents, such as loss of containment, that maybe people will be loss of containment. Here we are talking what's inside the pressure vessel or tanks, whatever we are talking about, fixed equipment, okay? Because like this, sometimes some equipment contain toxic fluids, some of them maybe also contain flammable fluids that may ignited with catch any ignition source, as well as there is some environment hazards. For that reason, we have That's our purpose as inspectors, okay, to identify that damage could result in the process safety incident. Also contribute to overall plant reliability to reduce number of duration of unplanned shutdowns. This is another purpose of the inspection. Our inspector it's working with the team to reduce the number of unplanned shutdown, or what we call the reactive maintenance, or suddenly shut down or something like that. Once you inspect the pressure vessel, or let's say pressure equipment in general, you can give good information to all parties related for the equipment condition, and therefore they will take that necessary actions to prevent from any unplanned shutdown for these things, like preventive or some corrective activity to be done. Also, this is another thing, is that in some countries or just jurisdictional authorities have regulation that's to be compliant or to be conform to be in conformance with the company insists to be in compliance with that regulation, okay, because that's effect on the many factors on the companies, okay, such like reputation and also license, and that can be found in some countries, US, Canada, and I think in Saudi Arabia and somewhere, even in Europe countries, okay. That's as a summary of or a general overview for the purpose of pressure equipment inspection. So another part from our definition of or cut of RBI as risk-based inspection. We talked about inspection, and now we are talking about the risk. What's the meaning of risk? The risk is combination of probabilities and event and its consequences, okay? In some situation, risk is deviation from the expected. When probability and consequence are expressed numerically, risk is the product. The risk, that's a probability, okay? Probability that mean potential or event that may happen and may not happen, that's probable, and it has some consequences after that happen. That's consequences sometimes to be adverse consequences and sometimes to be positive consequences. So as numerically in equation, risk equal likelihood multiply in impact, or we can say probability of failure, as we are talking about RBI, multiply in consequences of failure. That's we are going to discuss later when we are going to discuss talking about the implementation of RBI program. So the evaluation of inspection intervals. The inspection intervals that evaluated along the last decade or the last century up to date, okay? During or let's say from 950s, the concept of maintenance, and also let's say even because there is some relation between maintenance and inspection, they were thinking about, or they have like this strategy it calls reactive maintenance, or don't fix it, just keep it at till breaks, okay? Or there's another strategy said like run to fail. At the beginning of 1970s, the company started about a time-based inspection with the fixed interval for pressure equipment inspection, like every 2 years or every 4 years. And as I know, there is some companies still using this strategy up to now. Within 1990s, with the evaluation of API inspection codes, the strategy of half remaining life or condition-based inspection, even non-intrusive inspection, that started to be popular in this time, with all evaluation, as I said, by 570 for piping, pressure vessel for 510 and 653. At the beginning of this current century, RBI started started to be used with within the first edition of ABI 580. I remember, I think it is in 2002, and still continues up to now. And also today there is another techniques, or there is another strategy related to inspection intervals. It is called the digitalization, or with the revolution of the industry. That's what we call now. It is Industrial Revolution 4.0, or fourth generation of industry. Started to using the digitalization systems, such like Industrial Internet of Things, digital twins, and artificial intelligence, and so on. Now we are going to discuss about our main topic. It is the risk-based inspection, RBI. RBI, in fact, is an analysis methodology and process that opposite to condition-based inspection. That's what I was talking about. That's related to half remaining life strategy, and like 10 years or half remaining strategy, and so on. That's what included in the ABI inspection code. So it is requires, the RBI requires qualitative or quantitative assessment of the probability of failure and the consequences of failure. In fact, the RBI, it is the output mainly from RBI system or RBI program. It is inspection plan. That's inspection plan. How could you generate this inspection plan? It depends on the probability of failure of the equipment. I'm going to discuss what's the meaning of probability of failure, and how could you get, okay, or how could you calculate, and the consequences of this failure. So the most important thing, just to generate inspection plan to cover all of these factors, okay? Please, if possible, just mute your microphone. Some people talk about it. Anyway, so that's the probability of failure. Depends on the damage mechanism and the consequence of failure that associated with each equipment item, or piping circuits, or storage tank, in particular process unit. Anyway, RBI, what's the difference between the RBI and the condition-based inspection? In fact, RBI estimated that around 80% of the plant risk, in fact, is isolated about only or around 20% of its assets. This concept, or this principle, called Pareto. Pareto is an Italian scientist. Okay, he invented this principle, which states that for many outcomes, roughly about 80% of the consequences come from the 20% of causes. The principle of RBI, it is like this. Why do we need to inspect all our equipment? Why do we need to spend all of this money? Okay, why do we need to shut down our plant for a long time to check and to inspect or to verify the condition of our assets? while not all of them in the same importance for us. Same importance here, it depends on many factors. It depends on the business, and depends on the production, environment, safety, regulation, so on. So this is the main principle of RBI. Just we have about 80% or 20% of our asset, it is the most important for us, or it has the highest, the 20% only from our asset has high risk, and we have to focus our efforts on only of these assets. Okay. So what is the general approach of RBI? The general approach of RBI, it is ask what and where to inspect, because in fact, after when we are going to go to the program or RBI program planning or plan map or map process map for RBI, we will understand what's meaning of that. What and where to inspect, as ABI determine the inspection scope and prioritizing the component or the asset that make the concern, or the damage mechanism of this asset make concern of our business, or it will affect in our production or environment safety. So it is like a focus or concentrate the most important equipment. Then when to inspect, RBI, another mission of RBI program is to determine inspection interval also. How to inspect, this is another question or another purpose of or general approach of RBI, determine appropriate inspection methods. Once we define the damage mechanism, that's or potential damage mechanism of each equipment or each component of equipment, upon that or based on that, we will determine the appropriate inspection methods. This is one of the tasks to be done by once you are going to implement or to generate RBI program. So why RBI, or how could be management of RBI? In fact, if we are going to y-axis, as it is stipulated or illustrated, the risk and the level of inspection activity in x-axis, we found like a risk with a typical inspection program, where sometimes we were not, or we didn't define the right, or sometimes there is many inspectors, many companies, they don't have the system to define the damage mechanism of equipment, just to go with the normal or routine jobs that who have done by others in past, and they can't understand what's going on there, or what could they expect to find, or where to find the damage mechanisms, such like stress corrosion, cracking, CUI, corrosion under insulation, and so on. Okay, so the risk with the typical inspection program, sometimes you miss the location of potential damage mechanism, and the risk here, it will be high. So by using RBI and to optimize inspection program, because you made all the efforts, okay, to define the damage mechanism, to define the appropriate inspection techniques, entities, so on. By this way, the risk will be reduced significantly, but it will not reduce or decline up to zero, because there is still residual risk cannot be cannot be eliminated by even if you are using RBI. So in fact, this is only general because RBI or based on ABI 580, it is a complete course, and it is not easy to discuss all things in just only 1 hour webinar. Okay, so what's the benefits of RBI program? As we said, in fact, whenever you concentrate or identify what's the most important equipment for your business, by this way you will increase the facility availability. That means that your facility, it is operating smoothly and for long time. Okay, we can explain this in the just in case study in the next slide. And also improved reliability or sustained reliability, equipment reliability. Also focused inspection on high risk equipment. We don't need to, okay, it doesn't mean we ignore other equipment, but we can make another strategy for this one by on-stream inspection, maybe to expand inspection interval, not like what we were using during the like time-based inspection strategy or condition-based strategy, okay, or condition-based inspection strategy. Shorter and fewer facility shutdowns. Yeah, because by this way we are not going to make it like shut down every 2 years, or sometimes there is some companies or some companies are making every year annually. So by this way, this is one of the benefits of RBI program. A clear understanding of high risk equipment and ability to implement mitigation measures, identify deterioration modes and mechanism, and this is most important because based on that we can identify or identify the suitable inspection to catch this deterioration. Significant reduction in total cost of inspection, even though sometimes it is not related to total cost, because sometimes if you are going to make to capital stock of the RBI system for all, maybe this total cost of inspection for the future. Okay, so regularity, compliance, as we and also acceptance, as we discussed before, improved turnaround planning, and by this RBI we can know in future or in advance which equipment will be included in the next turnaround. Better informed, documented, and defensible decision. By this way, by this decision that's based on what we based on our efforts during the implementing the RBI program. By this way, we can say this equipment is higher, equipment is important, and or medium important, or only low important for our business. So this case study that you can find in the reference, this is an inspectioneering journal. So in this article, they made comparison between the time-based inspection and risk-based inspection for the gas treating units and the same plant. And based on a conventional or traditional way in turnaround, this turnaround takes about 8 weeks in past, and also over 100 people working in this turnaround. This about if they are working about 12 hours per day or something like that, it spent about 76,000 hours per hour for all persons. Okay, so when this facility implemented a risk-based inspection program, they found themselves just detect the turnaround duration about 50 days only, and only 30 to 35 people were working during this turnaround, and only they spend about 6,300 hours for along the turnaround duration. That cut about 30% of the cost of inspection and maintenance. And also we have to consider another thing. It comes from the using RBI program. Once you reduce the duration of turnaround and also the number of people working in the same area, by this way also you keep the safety of people. Okay, as you know, during turnaround there is scaffolding erected. There is some people are working with around, and actually anybody can ask safety personals or how they challenge all this situation during the turnaround. So this is case study, and for whom interested with he can go to the inspectioneering.com and found this article. It is very useful to read. Okay. So what's RBI standard and the quality practice references? As I know, our ABI, American Petroleum Institute, started with this methodology, okay, by generating ABI 580. That's risk-based inspection. This reference explains the methodology, general methodology. How could you calculate RBI? How could you calculate the consequence of failure and the probability of failure? All of these rules and guidelines in ABI 580. 581, that's risk-based inspection methodology. This is related to the quantitative approach. Also, there is ASME BCC 3, DMV RPG 101, and this is, and also European Commission released this RIMAP, that's risk-based inspection and maintenance for European industries. Okay, this is the available, as I know, this is available standards and recommended practice related to RBI. Okay, so what's equipment covered in RBI program? Here as we talked before, as this we are related to the fixed equipment. So RBI covers the pressure vessels, all pressure containing component, process piping, storage tanks, rotating equipment. In fact, pressure containing components of rotating equipment, not the rotating equipment itself, it is not covered by RBI unless the intercoolers and also, as you remember, it is pump and compressor casing. It is included in the RBI, as well as boilers and heaters, heat exchangers, such like shell, floating heads, channel, and bundles. All of these include in the RBI, as well as pressure relief devices, whether it is BSVs or relief valves. All of these covered. In fact, other equipment such like control, instrumentation, electrical, all of this, there is another strategy. It is related to maintenance. It calls RCM, or reliability centered maintenance. It covers it has like rules similar to the RBI, okay, and it's using for other equipment in the facilities, okay. So the types of RBI assessments. RBI assessment has three approaches. First, qualitative approach. This approach is based on engineering judgment, or based on information by engineering judgment or subject matter expert, or what, let's say, RBI specialist, or some SMEs related, also subject matter experts experience. And in fact, it is sorry, and experience. This is the basis for analysis of probability and consequence of failure. It depends on the subject matter expert versus to the quantitative approach that we are talking about. The inputs are given in data ranges. In fact, it is not like discrete or accurate values, okay? Such like quantitative approach. The results of the qualitative approach, it is typically given qualitative terms such like high, medium, low. This is in both, okay, and the probability of failure and consequences of failure, okay, or sometimes like high, high, medium, low, medium, and low, something like this, okay, or significant, not danger, risky, something like this, okay. Even though numerical values also can be used or associated with these categories, okay, but in fact it is sometimes like the qualitative approach, they are using this these terms, okay. A quantitative approach is another assessment approach of RBI. It is a model-based approach that's using numerical values like equations, okay, and gives you accurate and discrete input data used. This needs to the calculation, and also that's data you are using supposed to be accurate and discrete, okay. Also, it is more systematic, consistent, and documented, and they are easier to update with the inspection results. It's still more better than qualitative approach. This quantitative approach, even the qualitative approach using the software, but this one, because in qualitative approach, I have seen some companies are using the spreadsheets, sometimes Access, Microsoft Access for the qualitative approach, but the quantitative approach, in fact, needs to use software program to calculate risk and develop inspection program recommendation, also to calculate the inspection effectiveness, the damage factors, and so on. And ABI 581 describe and also explain all factors, and also all subjects related to quantitative approach. The third one, it is a semi-quantitative approach, and some company they are adopt this this approach when they are generating their RPI program. It is approach actually derived from both the qualitative and quantitative approach, because it is using the speed of the qualitative, because by qualitative, if you adopt qualitative approach, will be faster than quantitative approach, because quantitative approach needs to collect more data and also to make calculation and you get work hard, but as well as erasure of quantitative, okay. It is something like mixing between both approaches to generate the semi-qualitative. So implementation of risk-based inspection program. How could you implement your program? This planning process started with the data and information collection. All the most important thing is the first stage. You have to collect the data, because without data, and also you have to validate this data as well, to check the quality of this data and also information. By this, once you find yourself the data that you collected is enough, you can start it with the second stage, that's risk assessment process. As I said before, the risk, it is depending on the probability and consequence of failure. once you find the risk rank, or you find the risk, you can make a risk ranking. So inspection, upon risk ranking, you can generate inspection plan, even mitigation plan, if any, and it will be continuous development as reassessment. Once you found this one and you make inspection campaign based on the inspection plan generated by by RBI program, after that you collect all the information from inspection, and you have to validate the potential or suspect damage mechanism others. And let's say, like, sometimes you put some potential damage mechanism equipment, but after, and you upon that you make you identify the suitable or proper inspection technique to be used, and also the location, extent of inspection, all of this. And after that you carry out the inspection, but you didn't get any result, or you don't detect on any damage mechanism as put in the first or premise of information during RPI implementation. After that you can make reassessment, okay? And sometimes you and vice versa, sometimes you found that extent of inspection like 25% only from welding joints is not enough, because you found some welding joints deteriorated with like, for example, stress corrosion cracking, something like that, and you have to extend your inspection. Upon this reassessment or continuous development, you are going to put this data, and the inspection plan is supposed to be revised or updated. So the first thing for any initiative or a project, that you have to make your team, by together everyone achieve more. That's what meaning of team. So what's the RBI team? In general, RBI team, it consists of project manager, or sometimes called RBI champion. That's guy supposed to be has this like leadership skills, and also good experience and understand of RBI methodology, RBI generation, and it's preferably to be ABI 580 certified. Also area or unit inspector, process engineer, RBI or reliability engineer, operations representative, or representative 1 or 2 or 3, depends on the facility size, materials and corrosion engineer. And also it is not mainly that's only this guy, and also you can I can add another guy to be involved in this one as a risk analyst, okay? And sometimes maybe you can find some companies like they have all unit inspector and RBI as the same job or same position, okay? Anyway, it is not fixed, differ from the company to company, but and also sometimes that some company they hiring outsourcing, like they hire a subject matter expert, okay, from the contractor, or the hiring some contractor to generate or establish this system. But anyway, even if you hire contractor to do so, you have to your people have to be involved in this program, because they have a knowledge and experience about their equipment, and also about their data, their information, all of this, okay? In general, this is what also I'm discussing with the people, or whenever we are talking about RBI. This is what I believe. For any initiative, any program, any proposal to be adopted by company, if it doesn't get the top management support and commitment, in fact, this this project will be in the lockers, okay? because it cannot be achieved unless the top management understand what's the importance of this program. So this is also a recommendation can I give you, I can recommend you to do. You have to, whenever you discuss with your managers regarding this RBI, you have to speak with them the language that they like to listen. Like top management, always they are like for the cost reduction, production more, and so on. By this way, you have to understand that what's importance of RBI, and upon that you can discuss with them and convince them to adopt this program in your facility. Okay. So data and information collection, this is the first stage in the RBI program. So what's example of data sources like design construction records, inspection and maintenance records, operating and process technology, hazard analysis that came from the other like HAZOP project, material selection records, corrosion engineering records, library, database, cost and project engineering records. All of these data needs for the RBI implementation during the first stage. Typical data needed for RBI analysis may include but not limited to the following: type of equipment, materials of construction, inspection, repair, and replacement records, process fluid composition, inventory of fluids, operating condition. Inventory of fluids here also it is most important for the consequence of failure, operating conditions, safety system, so on, coating, cladding, equipment replacement costs, environmental remediation costs. Another stage or another phase of RBI implementation is probability, or sometimes called likelihood of failure. Probability of failure is the likelihood that the piece of equipment will fail or lose of containment that occurs due to the damage mechanism at given time. Probability of failure, it is related to time or proportional in time, okay, and or expressed by time or number by time. Probability of failure is calculated for individual pieces of equipment by looking the potential damage mechanism that's you can find from that all that information you gathered during the first stage, as I told you about, and or it could be susceptible to and general frequency of failures and management system factors. All of these calculated, the BOF probability of failure calculated. Actually, there is another causes of damage or failure, not related to the or loss of containment, not related to the damage mechanism, like seismic activity, weather extremes, sabotage, design error. That's sometimes happen, or design not not properly inspected during the fabrication. Or sometimes substitution of material of construction. You asked for something and you get it another thing, okay? Or this has happened actually in the carbon steel and low alloy steel, okay? For that reason, many codes or many even experienced engineers insist to make BMI or alloy analyzing during once you're receiving the equipment or new equipment, okay? Even overpressure due to pressure relief device failure. This is not related to damage mechanism. So the probability of failure is determined by two main considerations: damage mechanism and rates of equipment items, material of construction, resulting from its operating environment, that's damage mechanism, and the rate of this damage mechanism, and effectiveness of inspection program to identify and monitor the damage mechanism. So this is two factors: damage mechanism and effectiveness of the inspection program, and this one of the factors included in your RBI implementation, okay? So units measure for of in the what, how could you use these three levels of BOF, low, moderate, higher, or possible qualitative rank. This is for qualitative. Once it is this failure annual, or can be probability of the failure probability annually, it is less than 0.001, like between them, something like this. This is something like you can calculate it numerically, okay? And also there is another thing, 6 levels of probability failure, that, as I told you before, you can, in qualitative, you can just express in terms like this: remote, very low, low, moderate, high, high, very low. Okay, consequences of failure. It is another term or another part of the risk equation, or what called COF, is calculated by reviewing the ranking the potential consequences for the equipment, personal, environment, and in the event of equipment failure. This factor, or this part of RBI is calculated the potential consequences. What's hazard, or what effect, or what impact, what impact on the environment and the personal, even the company business, once the equipment failed. So by this way, you can by this calculation, you can find is it high, it is low, it is moderate, so on. Okay. COF provided discrimination between equipment items on the basis of significance of potential failure, and consequence analysis should be repeatable, simplified, credible estimate. Also, what's consequence should be typically be categorized. Okay, it is categorized as safety and health impacts, environmental impacts, economic impacts. That's what we are talking about. Like sometimes the fail of the equipment may shut down your facility, and every day equals money. Sorry. The major factors to consider in evaluating the consequences of failure should include flammable events, such like fire and explosion, toxic release of other hazard fluids. Also, the impact of these consequences and environment consequences. What could be happen in the environment? Maybe destroy the soil, production consequences, or business interruption. That means you stop your facility and the work, as well as the maintenance and reconstruction impact. This is another additionally, the impacts that should be calculated during consequence of failure analysis. So like these 6 levels: catastrophic, major, serious, significant, minor, insignificant. And also there is another 3 levels for safety, health, and environment consequences. And the high, what could be, what's the level of high, like safety consequences, such like maybe there is any loss of containment or release of the containment can make can consequently make fatality or injury of permanent disability. Maybe in the high makes long-term health effects, and so on. Okay, as well as for the consequences of failure for catastrophic, large number of fatalities. How could we category 1 or 2, major, like few fatalities, and or major short-term environment impact, and all of these units of measure in consequence analysis. Calculate the risk ranking. As I said before, risk equal probability multiply your consequences, expressed like this, and also expressed like high, medium, low, negligible, so on. So actually the risk here, as we can say here, the risk going like this diagonally. Okay, here from the low risk or negligible risk and go up to the high risk. Here you can find consequence of failure, probability of failure. So as I said before, the output of RBI assessment is inspection plan. Based on inspection plan, it will explain all concerns, as I said, extent of inspection, which NDE or which inspection techniques you have to use. Also, it is identify risk drivers, inspection methods that should be used, extent of inspection, percent of total areas to be examined or specific location, inspection intervals or next inspection date, other risk mitigation activities like CB or cathodic protection, using chemicals, corrosion inhibitors, and also the residual level of risk, as I showed you in the beginning, the graph, that there is still residual level of risk after inspection and other mitigation action have been implemented. And the last stage, as we talk about it, it is reassessment, or also it calls evergreening. But here reassessment, it calls about fully revalidate of your RBI system. But evergreening, that's what I talking about, that you check and you found some other places to be inspected, or you detect some deterioration out of estimated location during the RBI, that you can make it. But reassessment, it is complete reassessment for such after significant change, like process condition, amount of the time set by governing inspection code and jurisdiction regulation. Okay, so this is our main topic, guideline for selecting the right RBI software. Once you starting to think about the implement RBI program, firstly you have to think which approach you are going to adopt. If you are going with the qualitative, and that's what many companies do, okay, they start with the qualitative, after that go to semi-quantitative and so on. Or with the progress, they shifted to the quantitative. Okay, in fact, all of this approach needs software, but you know, software means money. Okay, that's what you have to think about. So the first thing you have to understand, or you have to think about before starting to purchase software, to business needs. What's your business needs? Identify your business needs. Are you going to cover all your plans? Are you going to only to cover that's important plans for you? That's all you have to think about. And also, who will be or identify key stakeholders in your RBI program: executive management, inspection teams, maintenance, operation teams. All of these will be will be included in the software or not, because some companies or some vendors offer the limited number of users. Okay, for that reason, you have to think about that. Are all of these, are all stakeholders will be involved in your program or not? So the first thing you have to know or understand your business needs. So what you expect, or what you has to put it in your mind before select the software. So, imagine that you get some offers from various companies. Okay, so how could you make comparison between them? First, the vendor supplier experience. You have to search about this vendor region, where he or it or she sell their software in North America, and Australia, Asia. Okay. So, because as you know, there is some difference in the weathers and the culture and many things. For that reason, you have to understand the experience of your supplier, which reason he or she worked, also which industry they provided their software before, and also if there is any after sale service. That's what you have to think about, like technical assistant, configuration, and other benefits you can get it from your supplier. Also, is the software compliance with the current code and standard regulation, like ABI 580 2016 or something, or ABI 581, that new edition in 2022 or 21. Software provides, if the software provides technical library containing relevant standards, recommended practice, material properties, such like ASME, ABI 571, 580, ASME 8, all of these, and also damage mechanism included, like as technical library. Okay, that's supposed to be in the software. Ability to include regulatory content and automatically create inspection plans based on local, state, federal inspection codes and requirements. That means that's auto updating. Is this software has ability to make auto updating upon any changes in the codes, like now 581, the last edition, I think, in 2016, and now there is a new edition. There is some changes in this edition. Okay, is the software, or maybe there is after sale servers from your vendor to set up or to make that updates on the, or sometimes there is some federal inspection codes, or like regulation or jurisdictional regulation has been regulations have been updated or changed. Okay, that's supposed to be the software you are going to purchase supposed to be capable to do so. Okay, ability to integrate with other work management systems, such like computerized maintenance management system, inspection data management system, and enterprise asset management system, and extra. Okay, so this one supposed to be, there is some integration. Is this software you are going to purchase can be integrated with your exist work management system or not? Okay. Now, because sometimes if you are somebody in the CMMS add the new equipment, that's supposed to be this equipment add also in the new RBI software. Ability to configure RBI tools to perform your own consequence calculation and model the damage mechanism. This software can make self calculation. Ability to support that change over from, like, you started with the qualitative approach, and after a while you decide to shift to the semi-quantitative or quantitative. So this RBI software supposed to be able to change or shift to these approaches. Also, ability to handle big data. So many provider or many suppliers now give that over to be the RBI software will be like web-based, still better than server-based. So I think this is still better to be like web-based. And after or at last, that's financial matters or financial issues, the cost of the software, and also the license fees, installation, also the training, because that's another factor. You have to ask your software provider, is there is any training, and this training will be advanced or cover all disciplines in the in the software or not, and so on. Number of users, also it is depends on financial matters, and also maintenance fees once any problem happen with the software. So the reference, my reference, it is inspectioneering.com, and this is also this is the one of the most incredible software, ABI 580 and ABI 581. Thank you for your attention, and I hope you get useful information of this webinar. And I will share my email for any further questions or contact, and you can find me also in LinkedIn in the same name. Thank you. Anis, if you hear me, you can just I will give you not to mute. And
yes, Abu Yunus, thank you very much for this webinar. And also, I just want to say all of the guys who are joining the link and from the website as well. Do you hear my voice clearly?
Yes, we are hearing you.
Yes, for all of us who is joining this webinar, can you please also share your email address for this attendance purpose? Because as we know, the API is requiring the attendance of the people who participate in this webinar. So for this purpose, if you share your email address in chat, and as well as if you are not receiving your certificate, you may just send me an email.
I think I can hear you well, Nis.
Yeah, I hear you.
Hello, do you hear me, Anis?
Yes, I hear you, Abu Yunus.
Okay, thank you, everybody, and we hope to meet in the next sessions and webinars. Okay, good night.